In Episode 12, titled 1.3, Choose Environments, Cloud Providers, On-Prem, Hybrid, Storage, Containers, the focus is mapping environment choices to risk, speed, and cost. Because environment is not just an IT preference, it is a set of constraints that shapes what data work is possible. The CompTIA Data Plus DA0-002 exam often frames scenarios where an organization needs to run pipelines, store data, and serve reports. And the best answer depends on recognizing what the environment implies about governance, performance, and operational burden. Environment decisions also carry cybersecurity consequences because where data sits and how it moves affects exposure, access control, and auditability. A useful way to approach this topic is to treat environment as a contract that determines who manages what, how quickly capacity can change, and what the long-term cost shape looks like. When those ideas are clear, exam stems that mention speed, compliance, latency, or cost often become straightforward. The goal is to make environment selection feel like reasoning about trade-offs rather than memorizing buzzwords. On-prem can be defined as self-managed compute, network, and storage, where the organization owns or directly controls the physical infrastructure and the supporting operations. This environment usually provides tight control over hardware, network boundaries, and local performance characteristics, which can be attractive when specialized requirements exist. The trade-off is that the organization also carries the burden of capacity planning, patching, monitoring, hardware lifecycle, and disaster recovery, because there is no external provider managing those layers. On-prem often has predictable performance for local workloads, but scaling can be slow because adding capacity requires procurement and installation rather than a quick configuration change. Exam stems sometimes signal on-prem with language about data centers, internal servers, fixed capacity, or strict local control, and the intended reasoning is often about governance and operational responsibility. A strong answer recognizes that on-prem is not automatically safer or cheaper, but it offers a different risk and cost profile. Cloud can be defined as managed services with elastic capacity, where a provider offers compute, storage, and platform capabilities that can scale up and down on demand. The defining feature is not that machines are somewhere else, but that many infrastructure responsibilities shift to the provider, such as hardware maintenance and certain layers of availability management. Elasticity matters because it allows workloads to expand during peak demand and shrink when demand falls, which changes the economics compared to fixed capacity environments. Cloud also offers many managed services, which can reduce operational overhead for databases, messaging, and analytics platforms, but it also introduces new governance and cost management requirements. Exam stems often signal cloud with language about rapid scaling, managed services, or global availability, and the correct reasoning often weighs agility against constraints like data residency and ongoing consumption costs. A candidate who treats cloud as a shared responsibility environment will make more accurate choices than a candidate who treats it as a magic solution. Hybrid can be defined as shared workloads across cloud and on-prem, where different parts of a system run in different places by design. Hybrid often exists because some systems cannot move easily, because regulatory requirements apply to certain datasets, or because latency and locality requirements demand that some processing stay near a specific environment. In practice, hybrid creates flexibility, but it also creates complexity, because data must move across boundaries, and identity and access control must work consistently in both places. Hybrid can allow an organization to keep a stable on-prem core while using cloud elasticity for burst workloads or new services, which can be an effective compromise. Exam scenarios sometimes describe legacy systems, partial migrations, or requirements that only apply to certain data, and these cues often point toward hybrid thinking. The key is to recognize that hybrid is not indecision. It is often a deliberate architecture choice driven by constraints. Storage choice matters because different storage types behave differently for performance, cost, and access patterns, and the exam expects a candidate to pick storage that matches the data. File storage is often associated with hierarchical paths and shared access, which can fit traditional workflows and certain applications that expect file semantics. Object storage is designed for large-scale storage of discrete objects with metadata, often accessed through identifiers rather than through directory trees, and it is common in data lakes and backup scenarios because it scales well and can be cost-efficient. Database storage is designed around structured access patterns, indexing, and query capabilities, and it often comes with stronger transactional and schema features. The decision signal in exam stems is usually the access pattern, meaning whether data is read and written as whole files, retrieved as object by key, or queried by fields and relationships. A good answer matches the storage type to the behavior, not to the name of the technology. Containers can be understood as packaged applications with consistent runtime behavior, where an application and its dependencies are bundled so the same environment can run across different systems. The key advantage is consistency, because the same container image runs the same way in development, testing, and production, reducing the "works on my machine" problem. Containers also support portability, which can matter in hybrid environments where workloads might move across infrastructures. The trade-off is that containers introduce orchestration and operational complexity when many containers run together, and they still require careful security practices for images, configurations, and access to data. Exam stems sometimes mention portability, consistent deployments, or microservices-style architectures, and those cues often point toward container concepts. The candidate is usually being tested on recognizing containers as an execution environment approach rather than as a storage solution. A data pipeline story helps compare environment fit because pipelines touch ingestion, processing, storage, and reporting, and each stage can have different constraints. Imagine a pipeline that ingests sales events from an operational system, enriches them with customer data, stores raw and curated versions, and then serves dashboards. In on-prem environments, the pipeline might run on fixed compute and local storage, which can be stable but can struggle with sudden scale changes during peak business periods. In cloud environments, ingestion and processing can scale elastically, raw data can land in object storage, and managed analytics services can serve dashboards, which can reduce operational burden. In hybrid environments, ingestion might occur near the operational system on-prem, while heavy processing and long-term storage run in cloud, which can balance locality with elasticity. This story makes the trade-offs tangible because it shows how data movement, latency, and control expectations differ by environment choice. Compliance, residency, and latency often become the deciding constraints because they shape what is permitted and what is practical. Compliance can require specific controls, audit trails, encryption expectations, and separation of duties, and those controls must be feasible in the chosen environment. Residency refers to where data is stored and processed geographically, which can be required by law, contract, or policy, and hybrid designs often appear when certain datasets must stay in a specific region. Latency matters when data must move quickly between systems because long network paths can slow pipelines and user queries, especially when interactive dashboards are involved. Exam stems sometimes include language about regulated data, regional requirements, or performance complaints, And those clues often indicate that environment choice must prioritize compliance and latency rather than convenience. A strong answer demonstrates awareness that environment decisions are bounded by constraints that cannot be wished away. Hidden costs are a major reason environment decisions go wrong, and exam questions sometimes test whether a candidate sees cost beyond obvious pricing. Data egress charges can appear when large volumes of data are moved out of a cloud environment or across regions, and that can make a design unexpectedly expensive. Idle compute is another common cost, where resources remain running even when workloads are low, which can happen when scaling policies are not aligned with usage patterns. Storage cost is often not only about the raw bytes, but also about access frequency, retrieval costs, and redundancy choices, which can shift the economics of keeping everything forever. Operational cost also includes the human cost of managing complex systems, because on-prem and container orchestration can require specialized expertise and continuous maintenance. The exam often rewards candidates who think in these broader cost terms rather than assuming that cloud is always cheaper or on-prem is always cheaper. Connectivity and identity planning prevents access bottlenecks, especially in hybrid designs where systems must trust each other across boundaries. Connectivity includes reliable network paths, bandwidth planning, and secure channels, and these details determine whether data movement is smooth or constantly delayed. Identity planning includes how users and services authenticate and how authorization is enforced consistently, because inconsistent identity creates permission failures that look like technical bugs but are really governance issues. In data pipelines, service identities often need scooped access to specific storage locations and database tables, and overly broad access increases risk, while overly narrow access can break workflows. Exam stems sometimes mention access problems, failed integrations, or inconsistent permissions, and those clues point to identity and connectivity as root causes. A professional approach treats identity as part of architecture, not as an afterthought. Scaling works best when compute growth is separated from storage growth, because compute and storage have different cost and performance behaviors. A pipeline might need more compute temporarily during heavy processing, but it may not need more storage at the same moment, so tying them together can waste money. Separating compute and storage also supports flexible designs where stored data remains stable while processing clusters come and go as needed. This separation often appears naturally in cloud designs where object storage holds data and compute resources are provisioned on demand to process it. On-prem designs can also separate compute and storage, but scaling either side requires procurement and planning, which changes responsiveness. Exam items that mention burst workloads, variable demand, or cost control often expect recognition that decoupling compute from storage supports elastic scaling. Resilience is built through backups and redundancy choices, and environment selection affects how those choices are implemented and how reliable they are. Backups protect against deletion, corruption, and ransomware-style impacts, and they should be treated as separate from simple replication, because replication can copy corruption quickly. Regional redundancy protects against localized outages, but it introduces complexity in synchronization and can introduce costs, especially when data must move across regions. On-prem resilience often requires deliberate investment in secondary sites and tested recovery processes, while cloud resilience can use regional options but still requires correct configuration and validation. Exam stems sometimes mention business continuity, availability requirements, or recovery expectations, and those cues often signal that resilience features must be part of the decision. A strong answer recognizes that resilience is a design choice, not a default property of any environment. A selection checklist for environment conversations can be held as a practical mental sequence that keeps trade-offs visible and avoids buzzword-driven choices. First, clarify the workload, including the need for latency, scale variability, and the sensitivity of the data being handled. Next, identify governance constraints like residency, compliance controls, and audit needs, because those may eliminate some options immediately. Then, consider operational capacity, meaning who will maintain the system and how quickly changes must be made, because the human factor often determines success. Finally, examine cost shape, including egress, idle compute, and storage behavior, because cost surprises often emerge from movement and long-running resources rather than from raw storage alone. This sequence keeps the conversation anchored in consequences, which is exactly how the exam tends to frame these choices. To conclude, environment choices shape risk, speed, and cost because they determine who manages infrastructure, how elastic capacity can be, and how data moves and is controlled. On-prem environments provide self-managed control with slower scaling and higher operational responsibility. Cloud environments provide managed services with elasticity and new governance and cost patterns. And hybrid environments combine both with added complexity in identity and connectivity. Storage types should match access patterns for files, objects, and databases, and containers provide consistent runtime behavior that supports portability but requires careful operational management. Compliance, residency, latency, hidden costs, scaling behavior, and resilience design all act as constraints that guide the best fit in a scenario. One useful practice choice is to pick a familiar workload, such as a reporting pipeline or a log analytics job, and state aloud which environment you would defend today and what single constraint drove that decision, because that habit matches the reasoning style the exam is built to evaluate. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.